Alright, welcome to the next major block of the course. At this stage, we have our structure complete, we started our enclosure, and we could go any number of ways. In fact, there's 3 parallel paths that go through the schedule. Once the structure is complete, we could start our enclosure, which we talked a lot about in the last many lessons. We can start moving in on the inside and start building our interior partitions, followed by our finishes eventually. And we can also start installing MEP systems, mechanical, electrical, plumbing, fire suppression. So for the course, we had to choose some sort of progression, and we started with enclosure. Now we're going to the architectural portions of the job. That would be interior partitions, finishes, specialties, furnishings, things like that. And we'll end the course with MEP systems. Knowing though that they're all dependent upon each other and they all happen almost at the same time in the project. So for this block of the course, we'll talk about a lot of the systems and materials that are designed by the architect on the inside of the building. And we'll start with this class, interior partitions. So interior partitions all fall under CSI Division 9, finishes, specifically gypsum board assemblies. And in the drawings, you can find interior partitions in the architectural set. And of course, the contractor involved would be the framer and drywall contractor. So let's get started. In this class, we'll talk about walls and partitions, and there's a difference between the two. Then we'll talk about framing. In almost all commercial applications, we have steel stud framing. Then we'll go into in-wall rough. Generally speaking, we're talking about MEP systems in this case. Once we've installed everything within the walls, then drywall's next, followed by drywall finish, and that's where we'll complete this class. So you see in the photo here, we have a little bit of everything. We have our steel studs in place, we have our MEP systems roughed in, we have drywall at the top of the wall, and it's also finished. I'll describe later why we finished it early, and why you have that technique at the top of a corridor sometimes. So let's begin. We'll start with the difference between wall and partition types. And the best place to start is to talk about fire and how to restrict the spread of fire through our building. Now on the job site, we often say, that's a firewall. And according to code, there's a few different types of fire-rated assemblies. A firewall is just one of them, so let's go through the differences. The first is a firewall, and a firewall essentially creates a new building separating different occupancy types within one structure. It's also required where buildings are tight and adjacent against each other on a lot line. This is also called a party wall, and you see this in an urban setting where there's no space between properties, and each structure is butted up against the adjacent structure all the way down the block. And even though it looks like one continuous property, they all must be treated as separate buildings using a firewall in between. A firewall must be capable of staying in place during a fire. It must be able to support itself structurally. It's often built from concrete, but it could also be built out of masonry. And depending on the application, code may require a 2 to 4 hour fire resistance rating for the firewall. And the wall must extend from the foundation all the way to the roof and exterior wall to exterior wall, one continuous fire-rated assembly. The next option is a fire barrier, and you see that in the photo here. A fire barrier is very similar to a firewall. Really, the only difference is it doesn't need to support itself structurally. So sometimes a fire barrier does extend from the foundation all the way to the roof, exterior wall to exterior wall, like I described with the firewall, but it can also extend from the floor slab to the deck above. And in that case, if it's relying on the floor slabs, it can't hold itself up, and that's when we call it a fire barrier. And often fire barriers are specified at egress stair enclosures or to separate different occupancy types within a building. For example, a high hazard area where chemicals are stored within a warehouse would likely need to be separated with a fire barrier. The photo here shows a rated fire barrier separating a process plant from a future office. And the two occupancies are going to be sharing this big concrete wall. So what we're looking at here is the completed process plant. Then an office addition is going to be built in the foreground. So very different occupancy types between the two. We had to build a separation, and that's why we built a 2-hour fire barrier. This was a concrete wall that extended from 36 inches below grade to well over 30 inches above the future roof line of the office, and you can see left to right it extended from exterior wall to exterior wall. You can also see the windows were left in place. Now, code is very specific about the permitted square footage of openings in any rated assembly. So we were allowed to keep the openings in the fire barrier, but we had to install fire shutters. In case of alarm, the fire shutters would shut, and we would have a continuous rated assembly. So similar to a firewall, a fire barrier, depending on the occupancies or depending on the scenario, could be anywhere from a 1 to a 4-hour fire resistance rating. Fire partitions would be your third option. A fire partition separates units of a residential occupancy, for example. It separates tenants in a shared retail location, such as a mall. And where we see this most often would be in corridors or elevator lobbies, where we need some sort of rated partition. And I describe in the slide 1 to 2 hour fire resistance rating. In some cases, you can go down to a half-hour fire resistance rating. And for all these different assemblies, firewalls, fire barriers, fire partitions, the code provides provisions and restrictions for openings in all the fire-rated assemblies, including sizes, material types, and ratings for doors and windows, for example. All penetrations need to be fire caulked. So you see in the photo here, a majority of our fire caulking is red in color, but it doesn't always have to be red. Red is one particular brand, and it's usually a good indication that you're looking at fire caulking, but red doesn't always indicate fire caulking. The point is, anytime we put a hole through a fire-rated assembly, we need to seal the gaps to make sure fire doesn't spread from one room to another. And this is one of many inspections that needs to be performed before the ceiling is buttoned up, whether that's an acoustical ceiling or a hard lid drywall ceiling. It's particularly important with a drywall ceiling because it's hard to get back up there. Fire dampers. So if a duct was penetrating through this partition or wall, then a fire damper is installed in plane with the wall. So if the building goes into alarm, the fire damper shuts and prevents fire from spreading through the duct from one room to the next. And we'll talk more about fire and smoke dampers when we talk about MEP systems. A stenciled rating. So what this means is you just spray on the fire resistance rating of the wall. This is done above the ceiling level, so you can't see it ordinarily. And it's just really good practice, but oftentimes it's required by a specification or local code. And what it does for you is later when you go to renovate this particular building, you know exactly what type of wall you have here, and you know you can't just start punching holes through a 2-hour fire partition without taking the proper precautions with penetrations. So I've noted fire resistance rating in terms of hours a number of times so far. The question comes up, how does someone know the material options or the combinations of materials to achieve a certain rating? Well, code is very specific in identifying methods to determine fire resistance, and it provides means to create your own assembly with backup, design documentation, calculations, and testing using procedures prescribed by ASTM, American Society for Testing Materials, which is now an international standards organization, or a UL, Underwriters Laboratory. And so you can do all that yourself, you can build your own assembly, but most often architects rely on established assemblies which have been deemed acceptable and published by the UL or listed specifically in the code. For example, if an architect determines that a partition needs to be a non-load bearing 1.5 hour rated assembly, there is an approved UL design for that assembly, complete with options for stud types, insulation options, gypsum board thicknesses, and number of layers. It even provides acceptable manufacturers and the specific manufacturer's product codes. So essentially, every time a design happens, the architect doesn't have to reinvent the wheel to determine their rated assembly. It's worth a quick search for UL-rated assemblies to see how much information is available. It's pretty impressive how many options are out there. Sometimes, though, a job site has unique conditions where an existing assembly just doesn't fit the situation, and in those cases, a new assembly must be designed according to the required methods allowable by code. And of course, all local authorities having jurisdiction need to be consulted before any given assembly is used. Okay, so that was all about fire ratings. Very similarly, we have smoke ratings. So smoke partitions and smoke barriers restrict the spread of smoke. So we have two options really for smoke assemblies. The first is a smoke barrier. And a smoke barrier is a 1-hour fire-rated wall creating a continuous barrier from the top of a floor slab to the bottom of the next slab above, limiting the spread of smoke. Like fire-rated assemblies, penetrations and openings in a smoke barrier have restrictions as well, typically requiring a smoke damper in the duct, which is very similar to the fire damper. In fact, there's such thing as a fire smoke damper. And we also have restrictions with our other openings, such as very specific tolerances for door undercuts and door reveals, along with sealing all penetrations through the smoke barrier. Our other option beyond a smoke barrier would be a smoke partition. The difference is this is a wall that is not rated. It's not fire rated. But it still extends from the slab to the deck. Or it could extend from the slab to the ceiling if the ceiling itself is built to limit the spread of smoke as well. Similar to a smoke barrier, a smoke partition often requires a smoke damper, sealed penetrations, and automatic closing doors along with tight tolerances for gaps around doors. And similar to the application with fire, we would have a stencil as well where it would say smoke above the ceiling line. Okay, so fire and smoke walls and barriers and partitions are most stringent, and that's why I started with those first, but we have a number of other options in the building. Okay, so another partition type would be a sound partition. And just like it sounds, it reduces sound transmission from one room to the next. And this is accomplished by insulating the wall and extending the partition from the slab below to the deck above and sealing all the penetrations in between. Now the photo here shows us a partition which doesn't quite get us to a sound partition. So we have all the joints in the drywall sealed, but you can see at the very top of the wall we're not sealed to the deck, and our MEP penetrations are not sealed. So that would be required to make this a sound partition, assuming there's insulation in the cavity of the wall as well. And you would use a sound partition in conference rooms or classrooms or an office setting, for example, to keep sound from transmitting from one side to the next. Another option would be a shaft wall. So if your elevator shaft was not built out of concrete or masonry, then it's probably built out of some cold form material, and you would call that a shaft wall. And a shaft wall is fire resistant, and it also withstands air pressure and suction from the elevator. You can imagine an elevator moving by really quickly would want to pull the drywall off the wall. So a shaft wall is usually an inch thick drywall, and it's a pretty burly assembly. And lastly, we just have our standard partition. And our standard partition might make up a good majority of the building, and this is typically a 3 5/8 inch stud with 5/8 inch drywall on each side, and this is common for commercial construction. So now that we're talking about specific stud sizes, let's talk about steel studs. So steel studs come in a variety of sizes. On a typical commercial job site, you'll probably see 3 5/8 or 6 inch. Now, of course, there's bigger sizes and it goes all the way down to 1 inch 5/8. And what we're looking at here is the web of the stud. In the flange of the stud would be usually 1 1/4 inch. And this designation of web versus flange is very similar to a channel like we talked about in structural steel. And lastly, we have the lip, and in this case I'm showing a 5/16 return. So let's look on the right. We have a 6 inch stud on the right side of this photo, and we have a 3 5/8 inch stud on the left. Typically speaking, you have a 3 5/8 inch stud. And typically you see a 6-inch stud in a wet wall. And what I mean by a wet wall is we're running plumbing through there. So this particular wall was in a lab, and so we had sinks lining this wall. It could also be in a bathroom, for example. So you want the deeper stud to allow you to install plumbing. Okay, so notice that we've only been talking about steel studs. Let's talk about the advantages and disadvantages of steel. First of all, a major advantage would be fire resistance. So that's why you almost never see wood studs in a commercial setting, because steel studs are fire resistant. They're also light. If you've ever compared a steel stud to a wood stud, steel studs are considerably lighter. And I don't know if this is an advantage or a disadvantage, but steel studs are screwed together versus wood studs, which are nailed together. Steel studs, as opposed to wood studs, they won't warp, they won't rot, they won't shrink, crack, or split. And if you've ever framed a home, you know that that's sometimes an issue. And steel studs tend to keep their true dimensions. They're easy to cut, and what I mean by that is you can use hand tools, such as a chop saw or a circular saw, or shears or snips. And you can do that with a wood stud as well, but this as opposed to structural steel, where you just don't use hand tools to cut structural steel. Holes are pre-cut through these steel studs, so you can see in the photo on the right, you can see all the pre-punched holes, and you can see in particular the flexible steel conduit being run through those holes. So that saves on labor where the electrician doesn't have to drill a hole through any studs, as opposed to wood studs. So if your framer is kind to you, they'll install those steel studs so that those holes line up and you can install your in-wall rough quite easily. And steel studs are a little bit floppy before you put them in place, but once they're fixed in place and you have drywall on the wall, then they are a very strong material. I mentioned this earlier, similar to rot, they're also impervious to pests, and also less susceptible to mold. Highly recyclable, but they're sharp, so it introduces a cut hazard. And they are susceptible to rust, because they're a steel material. And lastly, heat transfers through steel studs quite easily, so you're introducing a thermal bridge with a steel stud, which we talked a lot about during our enclosure class. Since we're talking about interior framing in this case, we don't have as much of a concern about thermal bridging. Okay, let's go through the sequence of framing an interior partition. So this is the sequence that I like to see. I like to have the framer come in first and snap the lines on the ground. Then our door frame installer comes in and installs the door frame, fastening it down to the slab. Then we have our top track installed by our framer, so the framer now moves in. And this is called a deflection track or a slip track. And it's used identically as how we described in infill framing when we talked about enclosure. And we'll see this better here in a minute when the studs are stood up. So our top track's in place, bottom track's in place. Then we start standing up our studs. So we would have king studs at openings, such as doors or windows. And usually those are doubled up or tripled up. And this provides strength, in particular with a door. When someone slams the door, you don't want to have a single stud there. You're going to get some movement in your wall, cracking of drywall, and you don't want that. Also at your openings, you have a header horizontally across the top of the opening. If a wall is non-load bearing, the header just tends to be a steel bottom track spanning across the door or the window frame. But if this is a structural load bearing wall, headers tend to be pretty substantial, and they tend to be built up using a combination of studs fastened together with steel track to create a more substantial member spanning the gap above a door or a window frame. There's also prefabricated headers to save time in the field. Okay, next we have cripple studs, and you see cripple studs between a header and the top track, or also between a sill and the bottom track. And then we have our studs, and studs are typically spaced 16 inches on center, and they just run wild through the partition at 16 inches on center. Okay, and then on the right, let's say we have a window opening. So we would stand up our king studs, build a sill for the bottom of the opening, supported by cripple studs. Then we would build a header across the top with cripple studs above that. The header would probably be a bottom track like we talked about with the door. And then we would beef up the jambs with king studs. And this would be an example where we maybe have a drywall opening through the partition. If we had a hollow metal steel frame, it would be installed similar to the door frame, where we would set it in place and stand up our studs on either side. So this is the basic assembly of a steel stud partition. And it goes very quickly, as you can imagine. The framers are really good at what they do, and they can fly through this assembly. Here's what it looks like in place. So we have 6-inch studs in the foreground, and you can see the king studs are tripled up in this case at the edge of this window opening. Then also you can see the door frame in the background, and we have our king stud tripled up in that case as well. Everywhere else you see 16 inches on center. And in the foreground you can see the bottom of the window opening is a top track representing the sill, and the top of the window opening is a bottom track representing the header. And you can also see throughout we have holes punched already in the steel studs and the electrician starting to run conduit. And that would be the next step. After we have framing in place, then the MEP system starts stuffing into the walls. So let's talk about that next, MEP rough-in. So now the framer is continuing elsewhere in the building. Their walls are in place, waiting for the MEP systems to go inside before drywall is hung. So as you can see here, we have some plumbing installed, drain, waste, and vent. And then you can also see on the face of this partition, we have steel strapping, and this is called backing. And in this case, casework would be installed later on the wall. And instead of having to hunt for a stud at 16 inches on center, we install this strapping so that we can hang the casework very precisely and have something substantial behind the drywall to hold up our casework. So let's talk about a few of the in-wall MEP systems. So shown here is a bathroom group. So the plumber in this case was on this project many months ago, and they were installing below grade utilities below the lowest slab, and then they had to go away for a while because we had to wait for the structure before they came back. And so for many years now, plumbers have been building their systems in the shop and then bringing them out to the site and installing these big prefabricated bathroom groups ready for walls around them. So in this case, the bathroom group went first and then the wall was built around them. But what you're looking at on the left is the drain, waste, and vent system, which we'll talk all about when we talk about plumbing. And this is all behind the wall. And you see on the right nearly the completed in-wall rough, where we have all the drain, waste, and vent in place, we have the potable water in place, and we're probably approaching drywall at this point. You also see instead of metal backing, we have wood blocking. And usually in a commercial setting, you can use wood blocking if you use fire-rated plywood. So in this case, it's most likely a rated wood. And just like in the bathrooms, all the different trades would have an opportunity to run their systems in the walls. Most often we're talking about the plumber, and we're talking about the electrician, and we're talking about the low voltage contractor. And we'll talk about all these folks later in MEP systems. But the general contractor needs to come up with some way to identify when a room is complete, when all the different systems are installed, before the drywall can be hung. And not too long ago, we did this system of spray painting, where every different contractor was given a different color of spray paint, and they would go in the room and spray paint the wall when their assemblies were done. When the general contractor went in and saw all the different colors on the wall, that meant that the subs were complete and we could hang drywall. Now we end up doing this on a shared drawing on the computer. So I'm not entirely sure I love the new way, but the new way is people walk out with a tablet, they identify the walls that are complete with the in-wall rough, and that is all compiled by the general contractor, who then transmits that to the drywaller. The drywaller then knows to start rocking the walls. I'm still kind of a fan of the old school way using spray paint. So in this photo, we're really close to installing drywall. We have our MEP systems in the wall, and in this case our partition required insulation. So our insulation's in place, now we're ready for drywall. Okay, so before we install drywall, let's talk about a few different options. So the first would be regular gypsum board. And regular gypsum board has a gypsum core and a paper face. And regular drywall is inherently fire resistant because it's made of that gypsum core, but it's not fire rated per se. Type X drywall is fire rated, and it has additives to the gypsum core, which enables it to be fire rated and have a UL marking on the back of the sheet of gypsum board. It seems more and more we're seeing Type X drywall specified for all locations, not just in rated assemblies. But of course your specifications would tell you that. Abuse resistant drywall. So this board resists mold, and it also has a greater resistance to surface indentation from abuse. You might see this specified in heavily trafficked areas or schools, or really any location where the partition might take some impact. Next we have mold resistant drywall. So the drywall you see on the right is mold resistant. Every manufacturer has a different color. You see blue board, purple board, sometimes green board, and it resists mold and mildew more so than regular drywall. So you'll see this installed in bathrooms or wet areas, and you might also see it installed when the enclosure is not quite complete, but the schedule is driving the interior partitions. So in that case, you may have water infiltrating the building, and you want to be extra cautious and not have any mold or mildew issues. Next we have sag-resistant drywall, and this board is a little bit lighter than regular drywall, and it's installed on ceilings. And because it's a little lighter, you're less susceptible to drywall sagging. So I would say that's not specified very often, but something to keep your eyes out for. What is specified very often in most applications, whether it's walls or ceilings, is 5/8 inch thick, typical commercial drywall. And you'll see this in almost all applications in commercial, except for in a shaft. So if you have a shaft board, that's typically that 1 inch thickness like I described earlier. So let's go through the installation process for drywall. Often a drywall company has two main crews. The first crew hangs the drywall, and they're often called the rockers, referring to sheetrock. After the drywall is on the wall, then the finishers come in, or the tapers, and they're a separate crew usually. So what we're showing here is the drywall recently installed on the wall, using screws to fasten it to the studs. And in this case we have penetrations through the wall. Now the duct could have gone first, or the drywall could have gone first. Either way, minimizing the gap around the penetration is a good thing. You can barely see this, but at the bottom of the drywall it says mold and water resistant type X. So that's a combination of fire rated and mold and water resistant. And this is a completed corridor. In this case we used the mold and water resistant drywall everywhere because our enclosure wasn't quite done when we were installing partitions. And this particular wall is ready for finish. So one thing to notice is this corridor is pretty jam full of MEP systems at the top. I mentioned earlier priority walls. So sometimes we install all the studs, then we install drywall at the top of the partition, and we fully finish it before we have any in-wall rough. And we do that usually on the corridor side of the wall, like you see here, because we eventually have to run MEP systems really tight to the wall. So in the usual sequence, we stand up studs, then run our MEP systems, then we install drywall. In this case, it would be really hard to squeeze someone up there to install that drywall and finish it. So a priority wall is installed to get the drywall in place so that you can then install the MEP systems and you never have to squeeze someone up there to try to finish the drywall. So now that the drywall's on the wall, the finishers move in to tape and finish the drywall. They first apply joint compound in the joints, and then they set tape in that joint compound. And the joint compound is typically gypsum mixed with water to form a mud, which is applied at joints and also at screw locations. It hides the joints and ideally will eventually provide a flat, seamless surface for the future painter or whichever wall finish is chosen. So there's a number of different levels of drywall finish. The first is a level 0, and this is gypsum board only. And you would really only see this if you have a future build out and you're not quite complete. It would be very rare to see a level 0 finish. Level 1 is usually your bare minimum, and sometimes you hear this called fire taped. Although it's called fire tape, that's really just a name. It's not actually a fire rated assembly. So level 1 is just tape, so one bed of compound plus tape. And typically you see this above ceilings in a plenum space, for example. So now's probably a good time to talk about the application of joint compound and tape. So for small quantities, joint compound is applied by hand with a drywall knife in the joint. Then tape is placed by hand in the mud. And tape is often a paper tape or a mesh type tape. So that process is rather slow. That's how I do it in my basement when I'm refinishing my basement. But for most commercial jobs, a tape tool is used and it's called a banjo. It looks like a big tape dispenser like you use when you're using packaging tape. It has a roll of drywall tape inside and also joint compound inside. And when it's rolled out, mud is already applied to the back of the tape. This saves a lot of time. Another option is called a bazooka, and it kind of looks like it sounds. The concept's pretty similar to a banjo. A bazooka has a long tube full of joint compound, and also a roll of tape on that long tube. And it's nice for reaching elevated locations, and it's also very fast. And every finisher has their preference for what they use, but either way, it's much quicker than doing this all by hand. And then you would let your joint compound sit overnight, and you would sand it, and then you would put another coat on. And this would be called a level 2 finish. So now we have one layer of joint compound over the tape. And you often see in garages and warehouses a level 2 finish. But if you're moving on to the next level, that's a level 3. You would let the level 2 finish dry overnight, sand it, then apply a second coat, which is a level 3. And you would do a level 3 finish if you were eventually going to put wallpaper on the wall or if you had some sort of heavy texture, because you can still see some imperfections in the wall and it's not entirely flat. So most often in commercial we go all the way to a level 4 finish, which is 3 coats, and you can see on the right this is a level 4 finish. And as we go up in levels, the knife gets bigger and bigger, and we start spreading that joint compound farther and farther from the joint, feathering it out, making a nice flat clean surface. So a level 4 is quite typical when you're eventually just painting the wall. Then you have a level 5 finish, and this is 3 coats plus a final skim coat, and you have this in museums, for example, where you need a absolutely perfect wall finish. And eventually you have a final skim coat over the entire wall, not just the joints like you see in the photo. So level 5 finishes are quite rare, unless you're in a really high-end facility. So this shows just the beginning progression of drywall finish. You can see we're taping all the joints and covering all the screw holes. And when you apply joint compound, the temperature in the room needs to be within the manufacturer's specified range for the application of the mud. Now, when you're outside that range, then you start running into issues with drywall compound not curing properly. So at this stage you might not be entirely enclosed, but if it's in the winter, you need to start introducing heat into the building. Okay, when you turn the corner, you use something called a corner bead, and this could be plastic, but most often it's a sheet metal product, and it's pre-bent to 90 degrees, and you tape it in place and finish over it. This gives you a nice clean line at your corners. And then this is how you sand between coats, and normally with typical normal joint compound or mud, it often requires a full day to let it cure before it's sanded, and then another coat is applied. Sometimes the schedule dictates that we go a little faster. So the drying process is important to prevent cracks, and so you can't just apply another layer without doing something different. And that something different is called hot mud, and that's quick setting joint compound to accelerate the curing process. And this allows for multiple coats in a single day. However, typically you don't use hot mud and typically it takes 1 day per level of finish. So it's typically a solid week after you hang drywall before you have your finish complete. Here are some examples of corridors that have completed drywall finish, and on the left we have a control joint. So usually in corridors where you have a really long partition, you need to introduce a control joint. For thermal expansion and contraction, you don't want to crack your drywall, so it's always specified when you need a control joint. And this is just a break in the drywall, and it's usually filled with a prefabricated metal strip to allow the drywall to expand and contract. You may also hear the phrase furring out a wall, and this would be thickening the wall essentially. And so on the left we have furring strips. So we have a drywall backing, then we install these furring strips, and eventually on the right we install drywall over those furring strips. And the reason we did this was eventually we were going to install wood panels below. So you see on top we have the drywall, and then the wall bumps in, and eventually we would have wood panels in its place. And this would give us one continuous plane once the wood panels are in place. Okay, that was interior partitions. And this is a major scope in the grand scheme of things, and it really changes the look of the job because now all of our rooms are in place. And it takes quite a bit of time to go through this whole process of framing, in-wall MEP, backing, insulation, then our drywall, then drywall finish. And when you're done with this, it represents a pretty major milestone to where you can start your finishes. And that's where we're headed next. We're going to interior finishes. And this could be our flooring, our paint, our ceiling material. We'll cover that all in the next lesson. We'll see you there.